Good morning, my YouTube viewers. It is Crystal here, and I'm just here this morning because I wanted to give you another code review. And this code review is going to be on reinforcement learning, which is something I don't have a lot of experience with. And since I don't have a lot of experience with it, that's why I'm doing the code review. And I got this off of an Edureka video, so you'll know where I got it. But I typed it all up and it worked, fortunately. And since I typed it all up and it worked, I thought I'd do a review of it. So the first thing that you want to do, well, the first thing that I did was I created this program on Google Colab, which is the Jupyter notebook that I tend to use whenever I'm working on Python projects. And the reason why is because it's portable. I can take it anywhere I want to take it. So the first thing I did after I created the program is I imported the libraries, and in this instance we're going to import NumPy as NP. And then I created the R matrix, and the R matrix is something that what you have to do is you have a series of rooms, a 1, 2, 3, 4, 5, and you have to move the pointer from your starting room to room 5, which is outside. And then before you do that, you have to create a matrix with your on pencil and paper, create a matrix on pencil and paper, and then decide how many points that you get whenever you move the pointer to the different room. And so they decided that they had a picture of the room, and then they decided that room number 5 you get 100 points. So this is going to be like 0, 1, 2, 3, 4, 5. So that's why you have 100 points. And then this is going to be like 0, 1, 2, 3, 4, 5. So at 5, 5 you get 100 points. At 4, 5 you get 100 points. And at 1, 5 you get 100 points. But that was something that was done before we wrote the program. You had to sit down and figure out how many points you were going to get for each move. And obviously I can't show you that here on this particular code review because I haven't got it. I was watching a video, and when I was watching a video they did that. But it's a diagram of a bunch of rooms, a bunch of squares, and each square is a room. And so each square is a room, and then so like when you move like from 1 to 2, you'll get so many points, and then from 2 to 3, you get so many points. And so that's the way it is. So if you get 0 points, that means it doesn't do anything. But if you get negative 1 point, then that means it's negative. So after we've created our R matrix, we're going to create our Q matrix. And your Q matrix is an NP matrix with 6 zeros by 6 zeros. Then we create gamma. Gamma is 0.8, which is something that's already been determined. We create our initial state equals 1. And then we create a function, def available actions state. Current state row equals R state. AV act equals np.where current state row greater than or equal to 0, 1, and then you return AV act. You get your available actions in the current state, so available act equals available actions brackets initial state brackets. You choose at random which action to be performed within range of all available actions. def sample next action available actions range. Next action equals int brackets np.random.choice brackets available act comma 1 brackets returns next action. Sample next action to be performed is action equals sample next action brackets available act. Okay, so now what we do is we update the Q matrix according to the path selected and Q learning algorithm. So it's def update current brackets current state action comma gamma colon max index equals np where Q action equals np max Q action and then 1 towards the end. If max index dot shape 0 is greater than 1, max index equals int brackets np dot random dot choice brackets max index comma size equals 1 brackets else max index equals int max index max value equals q square brackets action max index. And now you've got your Q learning formula. Q brackets current state comma action equals R square brackets current state comma action plus gamma times max value. I'll probably do that. And then you update your Q matrix. Update brackets initial state comma action comma gamma and then we do training. So now what we're going to do is we're going to train the model because in reinforcement learning it's done by trial and error. You don't have a data set. You don't get a data set to train on. It's just a training as trial and error. So current state equals np.random.randint brackets 0 comma int brackets q dot shape square brackets 0 square brackets available act equals available actions brackets current state brackets action equals sample next action bracket available act brackets update brackets current state comma action comma gamma brackets. And now we normalize the trained Q matrix, print trained Q matrix, and then print Q over np dot max brackets Q brackets times 100. And then so you get your trained matrix. And so that's your trained matrix. Because remember, we set the gamma up to 0.8. So now we're going to test the model, and your goal state is 0.5, and the best sequence starting from 2 is 2, 3, 1, 5. So I set it up. You can set it up for any number between 1 and 4, or you can even set it up for 5 if you wanted to. So I set it up for 2 because the 2 gives you the most paths that it has to follow. But if you want to set it up for 1 or 3 or 4 or even 5, you can. So current state equals 2, steps equals brackets current state, while current state does not equals 5, colon, next step, index equals np where brackets q current state equals np.max q current state brackets and then you've got 1 in square brackets. If next step index dot shape 0 is greater than 1, next step index equals int brackets np dot random dot choice brackets next step index comma size equals 1 brackets else next step index equals int next step index steps dot append brackets next step index, current state equals next step index. And then you go to the next column and it's print selected sequence of steps. So print selected path is, and then you print your steps. So I set it up on 2. So 2 will give you the, 2 will give you the most steps that it has to take. But what we can do is we can set it on 1. And then we can rerun it. And you can see that you've got your, there's your matrix. And you can see that you've got your selected path of 1 and 5. But if you want to set it up for 3, then your selected path is 3, 4, and 5. You want to set it up for 4. Selected path is 4 and 5. And if you want to set it up for 5, your selected path is 5. So we'll go back and set it up for 2 again. So that was a great little reinforcement learning program. I decided to go ahead and do this code review because you don't have a lot of code reviews on reinforcement learning, and that's something that sklearn doesn't cover. sklearn is Python's machine learning library, but it doesn't actually go into reinforcement learning. So it would be great if it did. And this is just a small little reinforcement learning program that I decided to do a code review on because there's not a lot on reinforcement learning. And I think I would like to do a blog post on it, but it is quite difficult. It's quite complex. And it would take me a while to do the blog post, I think. So, I'm going to go ahead and conclude this video. I would like to thank all my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you very much for watching my video. I look forward to making more code reviews for you in the future.